All right. Erica, can you read us the essential question, please? Perfect. And then Matthew, can you read us the I can statement?
How do you calculate the derivative of a parametric equation?
Perfect. So last time we just talked about what a parametric equation was, right? And we discovered that it basically was made up of two functions and it has a third parameter that we call time. Okay. When we graph it, it has a direction. So we put little arrows on it for the graphing piece. Okay. And really, we were just kind of trying to get the intro to what is a parametric equation and do the Algebra 2 pre-calculus version of parametrics. And then today we're going to move on to the calculus portion. Okay. It's amazing how easy now that you've done calculus for 2 years, how easy when you go back and do a little algebra, how easy it is. So, because parametrics really weren't a big deal. All right, I want you to take about 2 or 3 minutes, and I want you to read through both sets of boxes there. Okay. About 30 more seconds to read it to yourself. If you've read it once, skim it again. Okay, the first box is talking about a smooth curve. I'm not going to test you on smooth curve. It's there because the word smooth curve is in the theorem, the 9.1, right? That talks about parametric form of the derivative. So really in there, you had to have a smooth curve officially. It's all of our standard stuff, right? Both the x of t function, the y of t function have to be continuous on closed and differentiable on open. Sounds like the mean value theorem, right? And then if they both have to be, the derivatives both have to be continuous and are never zero. Okay, so both of these continuous and never simultaneously zero. If that happens, it's a smooth curve. Okay. Probably not going to give you one that's not a smooth curve. Probably wouldn't see one on the AP test that's not a smooth curve. Okay. Because they wouldn't be getting out of the question what they need to get out. They're not going to try to trick you. Okay. So in the blue box there, it talks about if you're given a smooth curve, you're given the equations x equals f of t and y equals g of t. So basically your functions. Then the slope of c, okay, so slope is another name for derivative, right? We've been learning that for 2 years. At xy is, so basically what you have to do is we're going to take the derivative like we always do, derivative of y with respect to x. The problem is that y and x are now separate equations. But y is an equation in terms of t. So we can take the derivative of y with respect to t, okay? And then x is its own equation, so we can take the derivative of x with respect to t. And then, of course, the condition is there that your dx dt cannot be equal to 0 because that would make it undefined, all right? So basically, you're going to do dy dt over dx dt. That's the derivative of a parametric, okay? So it's the only new thing you have to have learned, okay? Horizontal and vertical tangents. This should hopefully be something that we've remember from before. A horizontal tangent line, and this one might be need more of a refresher than vertical, but is basically you setting your numerator equal to 0. Okay, so when you set that dy dt equal to 0, you have a horizontal tangent line. vertical tangent lines, we know that y, or when your denominator equals 0, that's where we get a vertical tangent line. We've done that for a few years now. So that's setting the dx dt equal to 0 gives us a vertical tangent line. Okay. All right. I want you to read, let's see, is there a C on it too? No. Okay. So I want you to read parts A and B just to yourself. So take a minute and read example 4 to yourself. Both parts. Okay. So it looks like they give us a couple of equations, right? X of t equals 3t squared, y of t equals 2. Those are pretty nice equations. In part A, it says find equation of a tangent line to the curve when t equals 1. What two things do we need for equation of a tangent line? Point and slope. We didn't say that enough last year, I don't think. So those are the two things we need. We really only have t equal to 1, okay? I don't even have any part of my point because my point is an x value and a y value. I could pretty easily get my point though, couldn't I? Couldn't I take the 1 and plug it into both of these and that would give me point? Yes, that's what I'm gonna do. Let's start with point. So x of 1 and y of 1. So we do 3 times 1 squared. What's 3 times 1 squared? 3. Okay, and then we're going to do 2 times 1, which is 2. So I know that my point is 3, 2. Okay, if I really want to write it out like that, I can. 3, 2. Okay, in order to get the slope, what do we need to do? We got to find the derivative, right? So we're going to find dy dx, which we just learned is dy dt over dx dt. And then we're going to evaluate that at 1. Okay. All right. So I'm looking at my y first. What's the derivative of 2t? 2. Good. What's the derivative of 3t squared for the denominator? 6t. Perfect. Now I need to plug 1 into it. And remember the notation is dy dx when t equals 1 is typically what we would write if we're in this dy dx notation. So we've got 2 over 6 times 1. So 2 over 6, or what does it reduce to? 1/3. All right. So we're going to have equation tangent line y minus, what's the y value? 2 equals, what's the slope? 1/3 x minus, what's the x value? 3. Good. Okay. Notice we didn't even directly just do, hey, here's how we take the derivative. We went right into applying the derivative to something we knew from before. Okay, so I don't think that that's that bad. And look at how nice it was, right? They didn't give us anything with a weird chain rule or anything goofy in it. You probably won't see that a whole lot. All right, B is a little bit trickier. It's asking us to find all the points on the curve at which the tangent line is vertical, okay? So we're looking for points, and we want the slope to be vertical. All right, so we got to look back at what I'm going to go back and look at the definition of vertical again. So vertical says that we are supposed to set dx dt equal to 0. Technically, we've already done dx dt, haven't we? Isn't it right here? So I know that dx dt is equal to 6t. So dx dt equals 6t. I'm going to set that equal to 0. So what's t going to equal? T is going to equal 0. Good. All right, so I need to find all points. I have the t value. How am I going to get points? Do I have something I can plug into to get points? I'm not going to go to the tangent line. Can't I just go back into these guys right here, right? This is going to get me the x coordinate, and that's going to get me the y coordinate. And it also has a place for us to plug a t into, because remember, look at your equation of your tangent line. Tangent line doesn't have anything to do with t, does it? It has a spot for x and has a spot for y. Okay. All right, so I'm plugging into those two equations we had before, for the x and the t, or x and the y. So x of 0 and y of 0. X was 3t squared, so 3 0 squared. And y was 2 times t, so 2 times 0. In this case, what are both of them going to be? 0. So not super exciting. It just is the nature of this one was pretty simple. So I would probably write out that we have a vertical tangent line at 0, 0, or remember the fancy way we typically write a point in calculus is f of 0 equals 0. This is actually usually the preferred. You can write it either way, but that's usually the one you see typed on the test a lot. Say that one more time, Erica.
Because they were both 0 and you mentioned like a point, but if you got like 1 or 2 or something, or more, like you were writing it as a point.
Yeah, so let's say it came out, let's say it was 6t squared instead, right? Or something else like that. Or there was something where we could get, if it was, say, let's say this, 6t squared minus like 16 or something, not 16. Let's go 15. Okay, if I had something like this, so this is the what if case to answer Erica's question. We set that equal, that was our derivative, set it equal to 0, right? Get it to the other side. I think I do my arithmetic right? It's 9 when I subtract 6, or no, wait, divide by 6. What did I did not do my arithmetic right. I was dividing. Anyways, hopefully you get the idea. You get 15 over 6. And then take the square root and you'd have a plus minus situation going on. My numbers were terrible because I picked them out of thin air. I would have to plug both of those numbers in, so I would get 2 points. Is that what you were asking, Erica?
But our points, we would always write it as coordinates as well.
Either way.
Okay.
You can write it either way. Okay. So either one is fine. You need to make sure you recognize that this is a point, because that comes up a lot on the test. Okay. But as far as writing it, you can write it in either format. Okay. All right. Take a minute. I want you to read through example 5 on your own. So everybody read example 5. Okay, I want you to read it a second time, and I want you to underline what we are actually supposed to be finding. What is the question asking us to do? Okay, so what are we supposed to be doing here? Okay, find equation, and it's kind of hidden, right? It says find equations for these two lines. Well, we're looking for tangent lines. Okay, they're two tangent lines. So this time is going to be an example where we've got two of these things going on. Okay. All right. So the first, what are the two things, or it says it crosses itself at 0.04. So what two things do we need to find an equation of a tangent line? Point and slope. What do we have? We've got point. We know point is 0.4, right? I am missing slope. So how do I get slope? Derivative. Okay. So let's take the derivative of this thing. So our derivative, remember, is dy dx, which equals dy dt over dx dt. Okay, before I do it with you, try it on your own. Your dy, your x and your y are there. Okay, so find your derivative. Okay, so what'd you get for your numerator? 2t, good. Denominator? Good. Okay, so we've got our derivative. I need to plug some t values in. Do I have t values? The only things I have are x and y, right? So I need to actually figure out what t values I am plugging into this thing, okay, in order to get tangent lines. So in order to do that, I am going to take my x equation and set it equal to 0, and my y equation and set it equal to 4, okay? So that's going to hopefully get me my things that I need. So x of t equal to 0, and y of t we're going to set equal to 4, because that's what we know. So x of t is t cubed minus 4t, and y of t is t squared equals 4. Oh, it lost. I was writing, it must have lost connection. All right, so, well, it should say, oh, it must have lost connection a while ago, huh? Let's see. Let's see if I can get it back. It says it's connected still. All right, so while I'm working on this, I want you to go ahead and do t cubed minus 4t equals 0. And then your other one should say t squared equals 4. Okay? And solve those two. So did you get it? T cubed minus 4 equals 0, and t squared equals 4. So solve those two things. Okay? Well, it's going to take me a few minutes to try to get it back. So, because it's not even recognizing it right now. Let's go freeze, unfreeze. Doesn't like it. Just mess with this really quick. Okay. Go again. No, I won't let me do that. See how badly I can mess this up before class is over. It just turned off completely. I didn't do that. We'll see if it comes back on. All right, did we solve for our t values? That was interesting. I did not bring up a page on how to fix Bluetooth audio devices, but it just popped up on its own. That's interesting. Apparently it was listening to us. All right, once you have the two values, go ahead and plug both. There's three values, aren't there? I think three come up. Yeah, 0, plus, minus 2. Did everybody get those three? 0 and plus and minus 2. Plug all of those into your derivative, okay? And find your y values while I'm trying to get this to go again, okay? Let's go back there. Okay, that's what it's supposed to look like. Let's see if it picks it up this time. Okay, it should be coming back. Okay. Let's take a look at so that's what I got for my my values. Everybody good with the plus, minus 2, and the 0? All right, so first of all, if I'm plugging into the derivative, is this going to work out? If I'm plugging that into here, what's going to be the problem with it? Yeah, we're going to get 0, okay? It looks like it's okay in the denominator, but it gives us a 0 slope. And this is definitely not a 0 slope, right? We're looking at where these cross, and that's definitely not a 0 slope right there. It's probably talking about this tangent line down here, right? Might be talking about that one there. So we're gonna because of the nature of we have the picture there and we know the picture, we're not gonna use the 0. Okay. So we are gonna use the other two tangent lines. If you found it, that's okay. All right. Plus, it said that there were two, and these definitely have the same slope but in opposite directions. So that's why we're gonna use the plus and the minus 2. All right, so I'm going to kind of squeeze it in right here. So I've got dy dx when t is equal to -2. So hopefully you got 2 times -2 over 3 times -2 squared minus 4. All right, what's 2 times -2? -4. What'd you get in the denominator? 8. So -1/2. So the equation of that tangent line would be y minus my y value of 4 from up here equals -1/2 x minus 0. Okay, the other tangent line would be dy dx when t equals 2. All right, so I'm doing 2 times 2 over 3 times 2 squared minus 4. So what'd you get in your numerator? 4 over 8 again, right? So positive 1/2. So y minus 4 equals 1/2 x minus 0. All right, did we answer the question? Did we find what they wanted us to do? Go back and make sure. Yes or no? Look like we did it? Okay. All right, I want you to take a couple of minutes and I want you to read through all of example 6. Notice it goes on to the next page. All right, so read through the entire stem of the problem and then read parts A and B. Okay. They gave us some crazy looking equations this time, right? So they look a little bit different. They've got our velocity in there. It's more geared towards, see, they're talking about, I think the G is probably actually more of a gravity kind of thing. But we're just going to deal with the fact that it's got some weird variables in there, okay? And try to solve, the idea is we've got the T's. Those are the variables that we're focusing on, okay? So we've got this projectiles fired at an angle theta, where it's between 0 and pi over 2, horizontal to the horizontal with the initial speed of v sub 0 meters per second. So v sub 0 is our initial speed. Assuming no air resistance, the position of the projectile after t seconds is given by the parametric equations. X of t equals v sub 0 cosine theta times t, and y sub t equals negative 1/2 g times t squared plus v sub 0 sine theta times t, where t is greater than or equal to 0. Those are pretty crazy equations. We haven't seen anything like that before, okay? Remember, you're going to walk in on, I think it's May 9th, and you're probably going to see something you've never seen before. And you got to just not freak out and try to read what the question says and do the best you can to get to where you need to be, okay? All right, G is the G is acceleration due to gravity. So they have the velocity and the acceleration in there. What is the first question wanting us to find? What's A wanting us to do? Yeah, find the slope. Okay, we don't even need to worry about it. It says it's and we're supposed to leave it as a function of t, right? That means we're going to leave it in terms of t. The t is going to be in the answer. Okay, they did not give us a number to plug in. All right. It's obvious that it's parametric. It's not going to come out and explicitly tell you on the AP test that you're working on a parametric equation, okay? You have to recognize that you have an x equals t and a y equals t and that you have to do this parametrically, okay? So to find slope, what do? Got to take the derivative, right? So dy dx equals, and our new thing is dy dt over dx dt. Okay. Keep in mind that the variable we are taking derivative with respect to is t. Any other variable in the equation is going to act like a number, like a constant, okay, or a coefficient, all right? So we're going to take the derivative of y first. So I'm taking the derivative of this thing. So what is the derivative of negative 1/2 g to the t squared? So remember, we're working with the t. Where's the 2 going to land? in the front. So it would be like negative 2 over 2. What's that really? Negative 1. So I'm just going to write it as negative. The g is just going to act like another coefficient in front. So we're going to go negative g of t plus this is acting like a coefficient. It's acting like 3t. If I was going to take the derivative of 3t, what would it be? 3. Okay. So the derivative of this mess back here is just whatever this junk is inside those parentheses, right? V sub 0 sine of theta. Okay, let's look at the denominator. So I've got this weird coefficient and t. So what's going to be the derivative? Yeah, the weird coefficient, right? So V sub 0 cosine of theta. Don't go to college and call it a weird coefficient, okay? Just say V sub 0 of cosine theta, okay? But in here, you can call it the weird coefficient. All right, that's it. That's what they were looking for. Because we got the slope, and it's in terms of t, okay? It said as a function of t. That's what we got, okay? All right, let's look at part B. At what time is the projectile at its maximum height? Okay. Which variable typically deals with height? The x or the y? The y typically deals with height, right? Y is our height on our graph. So it really is happening when our derivative of the height part, the y part, is equal to, actually the derivative of the whole thing is equal to 0, right? That's when maxes and mins occurs, when derivative is equal to 0. So I'm going to take my derivative that I just got and I'm going to set it equal to 0. That's thinking back to, remember our critical numbers and our sign charts and all of that stuff. Our maxes and mins come from when derivative equals 0. So we're going to set our derivative equal to 0. So V sub 0 of sine of theta equals 0. Sorry, all over, it was all over the V sub 0 of cosine theta. No, cosine theta. All right, and I'm going to set it equal, the whole thing equal to 0 like that. Okay, and you might want to make a note out in the derivative equal to 0. That's what I would do if I was taking the notes. Okay, what happens with this denominator when I multiply it by 0? I get 0. Okay, so I really am just setting the numerator part of my derivative equal to 0. All right. I really don't know what I'm supposed to be doing. I need to go back and read the question, okay? Because I've got an equation and I've set it equal to 0. I know that's where my maximum occurs, but what are they actually looking for? So what are we actually trying to find here? We're supposed to find time. So what variable am I going to solve for? T. And I'm going to leave it in terms of all this other junk, right? I'm going to get t by itself. So I'm going to move this V sub 0 of sine of theta over. How do I do that? Subtract. And then what am I going to do? Yeah, we're going to divide by that negative g, double negative. What's going to happen? Positive. That's it. Okay.